with Lesson 1, Rational Numbers Part 2. Today's lesson can be a bit confusing, so again, rewind and watch it over again and see if it makes sense. If not, contact me or contact a friend that you think can help, and we'll sort it out. All right, just a quick review. We're talking about rational numbers, and you know that special word hidden in there, ratio. Okay, rational numbers are numbers that can be written as a ratio of two numbers, like a fraction. All right. Repeating decimals. All rational numbers can be written as repeating decimals. There are special types of repeating decimals where if the digit is a repeating zero, like the Terminator says, right, with all those repeating zeros, then we have a special name for those types of repeating decimals. Those are terminating decimals. Those are the decimals that you're most comfortable with are the ones that just end, even though really they don't. They go on forever with zeros. All right. So long division is a great way to turn fractions into decimals, taking the top dog and putting it into the division house there and dividing. All right. There's also another method you see right here, where if that denominator is one of those special denominators that goes into a power of 10, then you can convert that fraction to have a denominator with a power of 10, and that makes it easy to use the place values to write the decimal. All right. If we continue down, we get to these types of problems, number 6 and number 7, and that is where we have to focus today. All right, how do we write repeating decimals as fractions? Now, there are a couple little tricks, but we also have to have a backup plan that is a method that works in other at times when you don't remember the trick, okay? If you remember yesterday, any fraction that had a 9 at the bottom, wrong pen, right, like 2/9, that equaled 0.2 repeating, 3/9, that equaled 0.3 repeating, and so on and so forth. So if you look here at number 6 and you see 0.5 repeating, what do you think that would be? If there's one digit that repeats, only one digit that repeats, then you can just throw that over a 9. So that's going to be 5/9. Okay. Now if we go to number 7, your first step is to find that there is a integer there to the left. So in our answer, we're just going to throw in the 2 point. No, we don't need the point because we're changing to a fraction. We're changing that decimal part, the 0.18 repeating. We're changing that into a fraction. So what we can do is, since there are 2 digits that repeat, we're going to put it over 2 9s, all right? We're going to put the 18 on top, like that. And then since 2 digits repeat, we're going to have 2 9s in our denominator. All right, now this one does simplify, so we have to be careful about that. We can divide by 9 up top and divide by 9 on the bottom, so we get 2 and 2/11. All right, so that would be our fraction form. All right, now we do have to go over, let's go over these next two actually first, and then we'll get to the process that can be annoying and frustrating, but you're required to know it. So it's actually, I don't know, I think it's interesting. You guys will not find it super interesting, maybe more frustrating, but with some practice, I know you can get it. All right, let's do these two got it's. Why don't you pause, try them on your own, and then unpause and see if you did them right. So pause, try them, and then check. Okay, if you already did it and you're checking, good. Here we go. So we're looking at F here, and I know my answer is going to be negative, so I'll throw that in just to get started. All right, it's going to be a negative fraction because I have a negative decimal. So what are we going to do? We're going to count up the decimal places. That's tenths, hundredths. So we're going to put that over 100, it's going to be 14 over 100. Since both of those are even, we can divide by 2 on the top and the bottom, and we get 7/50ths. So our answer is going to be negative 7/50ths. Now, this next one is a repeating decimal. How many digits repeat? 1, 2. So we put the 27 on top, and we put how many nines? We put 2 nines at the bottom. Now, these are difficult to simplify sometimes, but it's nice when 9 goes into it. 9 goes into that 3 times, 9 goes into that 11 times. So our answer here is 3/11ths. Circle my answers. All right, so now we're going to go into a tricky process. If you could pause and get out a line sheet of paper, all right, you can copy down this procedure for turning repeating decimals into fractions. All right, we're going to start with 0.2 repeating, and we're going to change that into a fraction using this process. First, we have to remember that when we solve equations, or when we even work with equations, as long as we do the same thing to both sides, we will get an equivalent equation. An equivalent equation is just another equation that would have the same solution as our original equation. I'll do a little example over here. So for instance, if I had, let's say, x plus 2 equals 5, we know that what plus 2 equals 5? We know the solution is 3, right? X would be 3, that's our solution. That's the number that would make this statement true, this equation true. Well, we know that also if we add something to both sides, let's say I add 3 to both sides, I would get x plus 5 equals 8. Now, it looks like a different equation, but what is the solution to that equation? What number would make it true if I replace the x? 3, right? X would still equal 3. So that's one of the big principles that we're going to be depending on as we do this kind of convoluted and crazy process here. As long as you do the same thing to both sides, you'll get a new equation that still has the same solution. All right, so here we go. All right, so your step number 1 is going to be just make an equation. Make an equation. You're going to choose the letter n, a capital N, and you're going to set that equal to your decimal. All right, so that's step 1. I think we can all do that. Write an equation where n equals your decimal. All right, write an equation where n equals your decimal, step 1. Step 2, you're going to count how many digits repeat. So in this case, we have just the 2 repeats, 1 digit repeats. So we're going to multiply both sides of this equation by that power of 10. All right, so you're going to, how can I write this? All right, since only 1 digit repeats, we multiply both sides of this equation by 10 to the first power, which is the same as just 10. All right? Okay, so as long as we do it to both sides, we're going to get as long as we multiply both sides of that original equation by 10, we're going to get, n's going to stay the same, we're going to have the same solution. It's basically an equivalent equation. So we have 10n. Now this is tricky. What happens when I multiply by 10? It essentially moves the place value 1 over. So if it's just a bunch of 2's, right, 0.2 repeating is just a bunch of 2's. If I hop that decimal over 1 place, I'm going to get a 2 over here now, but still with a bunch of 2's afterwards. Okay, pause, rewind that if it doesn't make sense, and listen to it again. But when I multiply by 10, it moves the place value or the decimal over one place. Okay? Now, step 3. Another crazy, interesting step. Okay? What we're going to do is we're going to subtract original equation from our new equation. Alright, so we're going to do this. We're going to take this original equation up here, and we're just going to drag it down below our new equation. Okay, so that's going to be n equals, line up the decimal. Alright, and we're going to subtract. Alright, so we're going to subtract the n's. Well, that's 10 n's minus how many n's is this, from our original equation? That'd be 1n. So we get 9n equals, and what happens when I do 2.2 repeating minus just the 2 repeating? What do you think happens there? Alright, well, both of these sets of 2 here, they kind of just keep going on forever, but they'll keep subtracting forever as well. So basically, these guys cancel out, and we're just left with 2. And our final step is to solve the equation for n. So then we take this, we have to isolate n. So how do we get rid of a multiply by 9? We're going to divide by 9. We have to do it to both sides, so we make sure we keep our equation balanced and we keep getting equivalent equations. So this gives us n equals 2/9. If we look at the original, let me get a new color here. If we look at the original, n equaled 0.2 repeating. And now we have n equals 2/9, right? Since we did the same thing to both sides at every step, that means we're going to get equivalent equations from the beginning to the end. So therefore, these two are the same. All right, so 0.2 repeating is the same as 2/9, which we already knew because we had a shortcut. But there is our longer process. And that's all of that for today. We'll do some more examples of that in the future. Hopefully you have this in your notebook and something to refer back to, but it's something that we'll have to practice. All right, thanks for tuning in. Good luck.